During this webinar, we'll explore vehicle interior emissions regulations and methods for VOC analysis. My name is Lauren Armstrong, Marketing Director for Quantum Analytics, and I'll be your moderator for today's event. A really quick note about Quantum Analytics. We are a value-added turnkey solutions provider offering an array of customized instrument financing solutions combined with technical services, installation, training, and product support. I am really excited about today's webinar. Today's presenter is Dr. Ray Lee. Ray is the Environmental Marketing Manager at Marks International, the leading specialist in thermal desorption technology. This ends our introduction, so without further delay, I present to you Dr. Ray Lee.
Thank you, Lauren. First, I'd like to thank Quantum Analytics for giving Marks this opportunity to talk about some updates on the regulations and testing methods in different countries and international organizations for the vehicle interior air quality. Let's get started. Well, to improve and regulate the vehicle interior air quality, we need to know what chemicals are in the car cabin air. The air inside the car can be quite a complex mixture because you got all the different sources for the emission of a wide range of compounds. The typical car trim material include like plastics, foam, wood, leather, carpets, adhesives, also a big one for VOCs. And these different components and the materials can release volatile and semi-volatile organic compounds that may have negative impact on human health, such as the aromatics and also the formaldehyde, acetaldehyde, as well as the compounds specific to odors, such as reduced sulfurs, thermal labile, and the reactive species. So the health effect is really the main driver for the regulations of vehicle interior air quality. To assess whether or not vehicle interior air quality complies with the required levels in the regulations, a large number of standard methods for sampling and analysis of VOCs and SVOCs have been developed by the national standard agencies, automotive societies, and manufacturers. Generally speaking, the sampling methods can be summarized in these three categories. First thing we do to determine the vehicle interior air quality is to take a pump sample from the cabin. We're going to go into a little bit more detail about this further on in this presentation. Now you take a sample from the air in the cabin onto the sorbent tubes, where the VOCs and SVOCs are quantitatively retained. If we find something wrong with it, or some compounds have a little bit higher level than the limits, then we need to understand where they come from. So to do that, we look at the screening of emissions from different parts or from the materials that's used in the car. For the large components and assembly part, we can use smaller chambers or Taylor bags. For the components or materials, microchambers and direct desorptions are used. And this method can be very useful for quick screening of material emissions in QA, QC, or R&D on the formulations. Now, there are a lot of complexity involved in these sampling methods. You know, there are multiple standard methods to follow to comply to this different type of sampling. But the good news is that all of this analysis is done using the same instrumentation, which is thermal desorption GCMS. Now, if you want to look at formaldehyde or aldehyde, the only difference is that instead of having a sorbent tubes on the end of this sampling device, you will have a DMPH cartridge, and that DMPH cartridge will be analyzed by HPLC. So let's have a look at the more specific methodology. Historically, all of these regulations and methods have been set by the automotive manufacturers themselves or by national standard agencies. And they ask for vehicle cabin measurements. And this created the need for material testing. So after you have measured the air inside the cabin, and if there's something wrong, then obviously you need to be able to test the material inside the vehicle. So to test the vehicle interior air quality or the whole cabin air, you can use the ISO 12219 Part 1 or the China standard method HJ400 or the new UN specification. For the material emission testing methods, there are either screening using direct desorption, which is done by VDA 278, or a microchamber method according to ISO 12219 Part 3, or a smaller Taylor bag. If you want to test larger materials, then you'll be looking at assembly testing by a small chamber or a Taylor bag that's in much larger volume. One of the regulations that could be very influential to the global automotive industry is the amendment of the China new standard for the interior air quality. And this was launched by the Chinese Ministry of Environmental Protection, and they're going to make it mandatory. Now, this mandatory new standard it's going to cause a lot of concerns in Europe and the US, because what it meant is that every single car that is being sold in China will have to undergo the vehicle interior air quality testing. But it was unclear to some extent as how and when these vehicles will be tested. So what happens is that UN now is working together with the ISO committee, which represented a number of countries like China, US, EU, Korea, and they all come together also with the Chinese standard experts in this field, and hopefully to come up with a harmonized method. So in this new mandatory standard, you can see there's a reduction in benzene, toluene, dimethylbenzene, isobenzene, but also a dramatic increase in acetaldehyde. That's because it's really difficult to get down to the initial limit they were looking at the first version of the standard. So there are 8 compounds that are being regulated. You know, as important as to be able to quantitate every single of these, but we also need, you know, to So we also need to be able to address some other compounds. Like in China, the Chinese consumers are very concerned with the odor inside the vehicle. So obviously, it's also important to be able to understand those unknowns, the concentration of the compounds, ranging from those radic species with reduced sulfur species that has strong odors, and also to those SVOCs like the solids or plasticizers. Now let's look at Europe and the US. They do think a little bit differently from the Chinese. The air quality inside the cabin must comply with the list of compounds that are defined by individual regulator bodies in the Western countries. It is seen as a voluntary, although the car manufacturers do implement these across the board. Although it is not regulated by the government, not like in China, but it is carried out at a really high standard. So in the US, there's no actual regulations. The joint ventures between some manufacturers means the material producers will have to carry out the material emission testing to make sure their products are able to sell into the automotive industry. The US currently is working on transferring some of the ISO methodology into the specific US-based method. Now we just talked about all the different regulations. Let's look at how we do to carry out this vehicle interior air quality testing and how it actually works. So you would take a pump inside the vehicle with a sorbent tube attached, and you will take the temp through the tube. And usually the flow rate you're going to be taking range between 20 to 100 ml per minute, with a volume of 500 ml to 100 liters, depending on what type of compound you're looking at. And you want to make sure that the volume you take does not exceed the breakthrough volume for your compound of interest given sorbent. With multiple sorbents, compounds of much wider volatility range can be sampled onto one tube. Here's an example of a tube with 3 sorbent beds with weak, medium, and strong sorbents in order to trap the semi-volatile compounds, VOCs, and very volatile VOCs, respectively. You want to sample from the weak end and desorb it in a reverse flow so that the less volatile compounds will not stuck on the stronger sorbents. We talk about the sampling and regulations. Now let's have a look how the manufacturers going to make sure their products are suitable to sell to the automotive market. Because the automotive manufacturers are going to pass the responsibility of these regulations down to the material suppliers, so we're going to also have a look at some of the screening techniques. We mentioned the direct desorption method. Here we use the VD278 method as an example. You place the material inside an empty tube, you desorb it at 90 degrees for 30 minutes, and then you extract the compounds with volatilities up to C25. And then you can semi-quantitate the result with tolling equivalent. Then you keep the same sample, and then you desorb it again at 120 degrees for 60 minutes and extract the compound at a range from C14 to C32, and you semi-quantitate it with hexadecane equivalent. The problem with this method is that it is very difficult to turn this result into a prediction of vehicle interior air quality. It's a great method for just screening materials and just looking at the difference between a couple of variations, like different colors, different textures, but it doesn't really allow you to look at the specific emission rate. And we're going to talk about the specific emission rate in a little bit too. It's a very useful parameter. The ISO 12219 Part 2 determines the VOC emissions from parts and materials using bag method. Samples placed inside this bag, and then you flow the gas inside the bag. Then we mix the air really good with the bag. Then we draw the air onto a sorbent tube or directly onto a focusing trap, depends on which instrumentation you're running. There are also a few problems with this method. First, it's from the very nature of the bag. There are plasticizer used in this bag, and you have to make sure that you're using non-emitting bags. Second, also you want to make sure the mixing of the air inside the bag is uniform so that you are getting the real VOC concentrations. Third, the preparation and the conditioning of the bag can also be very time-consuming. Here we can see some of the bag materials that it's often used for the bags, and whether you want to decide which material you want to use. So we use a permeation device that allow you to inject a suite of compound underneath of the material to see how quickly or whether or not the compounds permeate through that material. This also allows us to understand if we get contaminations from outside air into the bag, or vice versa, the VOCs and SVOCs of interest may permeate through it, and nothing let us have a real result. So this graph on the bottom left shows the emission result of 5 different bag materials. Apparently, the PEHD is not suitable as a bag sampling material. I also want to talk a little bit more about the microchamber method. Here's ISO 12219 part 3 as an example, showing how the microchamber is used for sampling the vehicle materials. You could either place the whole material in the chamber to test the bulk emissions, or you can raise the sample to the top of the chamber and look at the surface-only emissions. The carrier of gas inside the chamber will swipe all the released VOCs onto the sorbent tubes. You can get the result of specific emission rate in unit of microgram per square meter per hour, or the VOC concentrations in microgram per gram or microgram per cube meter. You can then extrapolate this result into a much larger assembly surface area, and then you can predict this whole assembly's emissions to the inside the car. So this is very useful to estimate the contribution from different parts of inside the car. So this method is not only also used by the multiple manufacturers that goes to go to standard method for screening, but also written in regulations globally across the world for QA/QC of the materials used inside the vehicle. This slide shows the key parameters that's used in this method. The elevated temperature of 65 degrees C is used to simulate the scenarios of emissions when the car is parked under a very hot day. The microchamber essentially is a dynamic headspace, and all the VOCs are swept onto the sorbent tubes. The method by the General Motors basically is a duplicate of VIAQ we just talked about. But instead of having an empty tube, this method uses microchamber to sample the VOC emissions. So you also first heat it to 90 degrees C and then 120 degrees C. Alternatively, as mentioned earlier, you can also use the microchamber to determine the surface-specific emissions. So basically, you use a spacer that inside the chamber, and you raise the material all the way to the top of the microchamber, and with the lid, there's a collar that will seal only the surface exposed to the carrier. So only the VOCs from the surface will be released into the small space above the material, and the carrier gas will sweep everything onto the sorbent tubes. So nothing from the bottom, nothing from the side, only from the top. So you can prevent from, you can exclude the emissions from other areas, the impact from other areas. So this way you can also get the surface emission rate in microgram per cube meter, per square meter per hour. And then you can extrapolate the same result onto the larger area of this assembly or the parts, and to predict the emission inside the car. So here's the animation showing how the VOC is being swiped onto the tube. Now we have talked about the different methods, how they sample the materials or the air from the car. But another important aspect to make the results reliable is that now you have sample, you want to make sure that you are able to analyze the sample accurately. So here I'm going to spend a little bit of time talking about thermal desorption. There are two stages involved in the thermal desorption when you analyze sampled sorbent tubes. The first stage is tube desorption, and you have the option to split at this stage. So on the left-hand side, there are three different tubes. On the left-hand side is the sample tube. The middle one is the focusing trap on the thermal desorption unit. And on the right side can be a split tube, just collect whatever you split. Or it can be a recollection tube, essentially a clean, empty tube that you want to be able to quantitatively recollect the split samples from your original sample. So here it shows that the sample tube, it can be heated in a flow of carrier gas, and all the analytes will be switched onto a focusing trap, and this trap can be maintained between ambient to -30 degrees. The second stage is trap desorption, and also you have the options to split, which is outlet split. So at this stage, the focusing trap is rapidly heated in a reverse flow. It can go up to 100 degrees per second. So usually only takes 3 seconds to reach the setting temperatures. And all the compounds from the focusing trap will come off in a very narrow band and immediately goes on to the GC column. That will give you a very good sensitivity with the second stage focusing. Now on the right side, we mentioned is the recollection tube. You have the option to split your flow from the focusing trap onto a collection trap. The recollection is a very useful way to validate your results, and also to be able to save your results, because thermal desorption used to be just a one-shot method. Now with a recollection tube, you are able to reanalyze the sample if you have any questions about it. Or it's great too, just to help do a method development or troubleshooting. Here shows some of the examples of recollection as a tool to validate your VOC result or SVOC results, because a lot of people are wondering if all of the sticky stuff, especially the SVOCs, are coming through their system. So recollection can actually give you the quantitative validation result. So you can see on the first panel on the left upper corner, it shows original sample result. And also, you recollect of that sample and you reanalyze it. So it shows the first recollection results. And while you analyze the first recollection sample, you can still recollect that one, and you can recollect the second recollect sample again to get the second recollection result. So you can compare all the three different samples. They are essentially the same sample, but if they're quantitatively retained each time, then they should be the same. So you can do this as many times as you want, and they're all going to follow the same theoretical ratio. If it is, say, 10:1 split ratio, then it will always add that ratio to decay. So you can easily to compare your results to the theoretical decay. So on the left bottom graph, you can see there are two different lines. The right line is a theoretical decay. So you have one sample and you recollect it 20 times, and it will decay, follow this red line. But also, you take measurements each time of your samples, so you also get measured results. If the measured results are perfectly matching the theoretical results, then apparently all the compounds you're interested are coming through your system, and they are being quantitatively analyzed. So on the right bottom corner graph also shows that it can do up to C44 with recollection and with our thermal desorption system. Now we have talked about the regulations, the sampling methods, and analysis. To conclude, why the message I'm talking about, why we want to do the screening of the materials, because doing screenings allow you to predict the results for longer, more expensive tests, like bag methods or small chamber methods. That sometimes it takes a couple days to a week to do a robust result, and allow you to show uniformity across a range, like different colors, different shapes, using different formulations to compare the different things in the same material. And also it allows you to troubleshoot some of the customers' complaints and compare the products with competitors. Also determine the new formulation for low-emitting products. And also we mentioned that odors in some of the countries are also very important. It's a big concern. So we also want to show how the odor emissions looks like with the different materials. Now with the sampling methods, you want to make sure your sampling methods have the correct parameters, and it has the same, the right temperature, flow rate, and you are using the same sorbent tubes. You are not sampling, your sampling volume are not going to break through. And if there's a water, high water content from the material, you want to make sure you choose the right parameters to be able to purge off the water, or choose hydrophobic sorbents to make sure less water are coming into your GC system. Now, in the end, when you analyze, you want to make sure you can validate your results. And this is very important, very useful for QA/QC, and make sure your calibrations are accurate. And you want to make sure you have a very good desorption efficiency as well. These all can be achieved with recollection and with the right method settings.